Ladies and gentlemen, welcome back to yet another video. I'm tweaking right now because I have messed up my name on this paper 4 times in a row. That is not an exaggeration. And yes, I do feel stupid. In case those were I keep clicking the same camera instead of the one that I'm supposed to be switching to. Alrighty? So instead I just wrote J Swizzle. Alrighty? I didn't give myself the LE. Beautiful. Anyways, today we're going to be talking about some practice on these triangles. I'm not going to do all these. That would take me forever. Not that it would take you forever, all right? You don't have to explain them to someone. You just have to do them. They don't take you that long, guys. These are memory ones. If I didn't have to explain, it would not take you that long. You could just look at the picture, okay? So, be advised, these triangles are on the formula sheet for geometry. So here, you can see there's 2 very special triangles, the 30-60-90 and the 45-45-90. We said in class that these triangles exhibit a particular symmetry, which allows us to reduce the degrees of freedom. Or, in layman's terms, these are really easy. These triangles are free, okay? So, what we'll do, essentially, since they have very easy angles, it makes the sides really easy too. In any case, what I would do for these problems is basically just look on the formula sheet, and I'm going to show you a way in a second, but we're going to look on the formula sheet and then calculate what we think is the best option. So I'm going to draw a picture here so that I can have more room. We may need more room to write my thoughts down. I'm going to try number 1 here first. Alrighty? For number 1, this is a 45-45-90 triangle. If you're curious, you could just take 180 and subtract 90, then subtract 45 to get that this also has to be 45, okay? Since this is a 45-45-90 triangle, we know that it has to be isosceles. Its base angles are the same. So if this is 13, x must also be 13. Alrighty? First one done. That's it. That's your answer. Box it in, chief. Then, for y, now this one's a little bit weirder. We know... Now, you could do Pythagorean theorem. Like, let's say, for example, a squared plus b squared equals c squared. Anytime you have a right triangle and you know 2 sides of it, you can use the Pythagorean theorem. And in this case, no, this is no different. We can just plug in 13 squared twice. Alrighty? But inherently, the thing about you can kind of see why the Pythagorean theorem may not have to be used here. Because there are 2 13s. They're the same number, right? So in any case, we could take... I'm not even going to write this fully out so I can show you what happens. Alrighty? I'm going to say, guys, isn't this the same as there's 2 13 squareds is equal to c squared? And then I'm going to square root both sides of this. Okay? So here I get c is equal to the square root of 2 times 13 squared. And now if I were to simplify this radical, do you guys see something cool? Look at this. Radicals like pairs. They remove pairs from the radical. And look at this. That's a pair of 13s. So 13 gets to come out of the radical. And we're left with 13 times the square root of 2. That is our reduced form and our answer. So if you know Pythagorean theorem, if you know 2 sides and Pythagorean theorem, you can use it. But if you realize, guys, nothing is special about the 13 in this equation. This could be any number. It could be x, right? And then you would have x times the square root of 2. And this is what the formula sheet is trying to tell you, okay? The formula sheet is trying to say, if you do Pythagorean theorem, then x gets to come out of the radical, and you're just left with x times the square root of 2. So... if you know that, you don't have to do this every time. You can do like this one here. We see that 30 is equal to, and we don't have to do all this math again. We know that 30 is equal to x times the square root of 2. And so to solve for x here, we could say x is equal to 30 divided by the square root of 2. But there's a problem here. If you're taking 30 and dividing by the square root of 2, maybe this feels queasy to you. I don't know, but you may have talked about it in Algebra 1, okay? For us, 30 over the square root of 2. And by the way, these are the same. The fraction bar being sideways doesn't really matter. That's just a way of writing it so that you could use less room. Okay? 30 being divided by the square root of 2 is not possible. How do you divide by an infinite number? The decimal of root 2 never ends. If you wanted to calculate 30 divided by the square root of 2, the calculator would literally have to spend all of eternity on number 2 on your homework problem. Okay? So, now I'm just kidding. I mean, modern day calculators are so fast that you could get a very accurate approximation of this number very quickly. Okay? But if for some reason you need the exact value, like if you're building a rocket ship or car or, I don't know, airplane or something like that, alrighty, you would simplify this. And the way to do this is by multiplying by 1. Okay? Multiplying by 1 does not change the value of your answer, right? So if I multiply by 1, I'm not changing the number. My answer stays the same, but I'm not going to multiply by just any 1. I'm going to multiply by the square root of 2 on the denominator. Okay? If I choose to multiply by the square root of 2, I could eliminate this radical in the denominator and thus be doing a simpler problem. But to do that, I need to put root 2 on the top as well. Okay? So what I'm saying here is, isn't root 2 divided by root 2 equal to 1? So, no magic. This is not a magic trick. If I multiply by root 2 over root 2, I haven't changed the value of my equation. And now, normal people here, maybe a regular algebra student would say, well, doesn't root 2 and root 2 just cancel? So what's the point? You just get back the same thing. And you're right. That is true. Okay? Since root 2 and root 2 cancel, you're right, you get back to the same thing. But why would you cancel them? You don't want to cancel them, right? Instead, let's multiply fractions first. 30 times the square root of 2 on top is 30 root 2. And root 2 times root 2 on the bottom is 2. Alrighty? Remember that the square root of 2 times the square root of 2 is root 2 times root 2, which is actually root 4, which is actually 2. Okay? Remember, radicals love pairs. Radical loves pairs of numbers. Well, I shouldn't say that. The square root loves pairs. If it's cube roots, it loves threes and so on, and triplets and so on. Anyways, we get 15 times the square root of 2 for our answer. Wow, look at that. So here what we'll do is put that down for x. And since we know that this triangle is isosceles, we can cheat and get the next answer too. Very nice. So if you're looking at this problem, again, you do not have to do this every time. Again, you do not have to do this every time. If you notice the pattern, there's nothing special about 30. Okay? We are going to have to, like, root 2 is consistent. It's always in this triangle. So you're going to have to rationalize out a root 2 every time. What you could say is, then, you could just take 30, divide by 2 to get 15, and then tack on the root 2 since it doesn't appear in the problem. Okay? Don't make this hard on yourself. I'm just giving you reasons why things happen. I don't think it's enough to just say things. I like to explain. Okay? Now, this triangle is different. This is our good friend, the 30, 60, 90 triangle. Don't look at that face. Jump scare, bro. All right? 30, 60, 90 triangle. This guy, and this one is flipped around. It's a 180-degree rotation. But we see that the short leg is x. And the way we figured this out was we actually took this triangle, duplicated it, flipped it over, and then used an equilateral triangle to figure this out. Okay? Anyways, we see that this side is x, this side is x root 3, and this side is 2x. So, in my marker, that's what I'm going to say. Typically what you do is, like, you start with what you have, and then you get to something easy, and then you keep going and get to another thing easy. All right? Anyways. So, on this particular problem, let me get some paper and cover that up. Oh my God. That's so funny. We have, on this problem, totally lost my train of thought. Completely gone. All right, so if this short leg is 3, we know that x has to be 2 times that in this case. So we double to get 6 here for x. All right. For y, we know that it's equal to x times the square root of 3, so we simply just tack it on. 3 root 3. Ready? The number does not change. It's root 3 every time on the 30, 60, 90 triangle. It's root 2 every time on the 45, 45, 90 triangle. Okay? And we can keep going here. Let's try another one. Let's do, this one is not too bad. I'm going to go for, that one's not too bad either. Let's keep going. I'm going to do this one, all right? This one's a little weird. So on number 8, you're given the long leg of a 30, 60, 90 triangle. I know this is the long leg, not only because it looks longer, but because it is across from the bigger angle, right? Never forget the Alamo, right? Hinge theorem. The wider a door is open, the wider its doorway, all right? So in this case, since 60 degrees is more than 30, I know that 24 is more than y. Alrighty? Anyways, now this is equal to, 24 is equal to x, or I should say y here, sorry, y times the square root of 3. Okay, so if I want to get y alone, I'm going to need to divide by the square root of 3. And the same thing is true here that we just tried earlier. You cannot divide by the square root of 3. It's inherently irrational. So to solve this, we'll do 24 divided by, I'm sorry, I didn't mean to do that. I'm thinking of my paper. All right, we'll get our paper out. And here we'll do 24 over root 3. And again, one more time, we're just going to show the full steps. All you do is multiply by whatever's in the denominator on top and bottom. And then you choose to multiply fractions instead of canceling. So 24 root 3 on the top. And multiplying fractions is heaven. So easy. You just do top times top, bottom times bottom. And then square root 3 times square root 3 is 3. For the same reason. Root 3 times root 3 is root 9, which is actually 3. And then we'll do equals. 24 divided by 3 is 8. And we leave that square root of 3 on there. Okay? Very nice. These numbers don't always divide, but sometimes they do. So the same thing is true. On this one, when we had it equal to root 2, we divided by 2, then tacked on root 2. When it's equal to root 3, we divided by 3, then tacked on root 3. Alrighty? Very cool. You can imagine if it was root 5, you would divide by 5 and tack on root 5. Okay? Depending on the kind of person you are, make it easy on yourself. Okay? You don't have to do this my way if you hate it. And then let's do, so anyways, we took 24 we got here by dividing by the square root of 3. Now we're going to go from y to this. To be able to do that, if I'm looking at my pictures, like see, here's my arrows here. Alrighty? We're starting at x root 3, then getting to x. So we took away the root 3. Now we got to put on the 2. So we'll multiply this answer by 2, and 2 times 8 times the square root of 3 is just 16 times the square root of 3 for our final answers. Very nice. Nothing crazy here at all. Alrighty? I think I'm going to show, some of these have been weird, so I think I'm going to show, people haven't asked me a lot about number 7. I think I'm going to show number 7, number 11, and then maybe I'll do a hard one. We're already at 13 minutes. I'm kind of pushing my limit, pushing my luck here. There's a lot going on. It's only a matter of time before I make a criminally difficult mistake and then everyone bullies me in the chat. 7, 11, and then let's do, maybe I'll show one of these other ones, one of these other cool ones. Maybe we'll do that one, which also looks like a geometric mean problem. No way. Okay. I kind of want to leave that one for you guys. That would be fun. I don't want to spoil the fun on that one. Let's see. Do I have another page? There is another page in the back, I think, for you guys. Oh, yeah. There's some good ones on here. Oh, yeah. I will show those. Yes, I'll do 21 and 22. So I'll do these two, and then I will show 21 and 22. Guys, you don't have to do all these problems, obviously, but you cannot imagine how helpful it will be on the formative if you have done them all, okay? I cannot express to you. I'm pretty sure for the formative, I just screenshotted like 3 of these randomly. So if you know all the answers, you can just copy them. All right, anyways. So on this particular one for number 7, got a lot of questions about this so far. What I would say, you're starting out, a lot of people say, well, like, it's supposed to be 2 root 2, right? Like, isn't it supposed to be equal to something's root 2? Yes, you're right. It is equal to square root. There is a square root of 2 in this. There has to be, so that it looks like this. But it's kind of like these problems earlier. I mean, there's a square root of 2 in this too. I'm scared. There's a square root of 2 in this too. But we had to divide it out. I mean, just because you can't see it doesn't mean it's not there. You can divide it out anyways, right? So over here, the same thing is true, but something cool happens. 14 is the same as 7 times 2. This 2 is under the radical. So if we were to divide this by the square root of 2 to try and find one of the sides, this 2 and the square root of 2 cancel. These guys are the exact same thing. Guys, remember, radicals do not care about multiplication or division. They do not care. So here, this is a 2 under a radical. This is a 2 under a radical. And since they're being divided, you can cancel them. And we'll get 2 root 7. And I shouldn't say you can cancel them. Really what's happening is you're taking, the square root above both, and then you have a root 2 and root 2 gone. Alrighty? So 2 root 7 is the simplest form for both these answers. Nothing is stopping you from, let's just to show it, okay? If you had instead chosen to take 2 root 14 and then divided by the square root of 2 and then rationalized your denominator, you would see that 2 times the square root of 2. Alrighty? We just multiply them all. And then here, root 2 times root 2 is 2. Look at this. Isn't that odd? Isn't that fascinating? Alrighty? So maybe you say 2 and 2 cancel. And it's starting to look weird, like my 2's went away. Well, 14 times the square root of 14 times the square root of 2 is equal to the square root of 14 times 2. And there's a factor of 2 in this 14, so we can make a pair. Alrighty? Another reason math teachers like reduced radical form is because it's very easy to tell, no matter what math you did, like even though this person, a person who does the problem this way, has a long-winded explanation, they still arrive at the same thing. Okay, and reduced radical form is just nice for that reason, I guess. So let's try number 11. Gosh, I literally cannot breathe. I don't know what it is, but it just will not go away. Okay, here I see that this is 10, so I'm just going to jump straight to x and see that it's also the square root of 10. Sorry, I shouldn't say 10, but the square root of 10. And then here, for y, I know that to get from x to y, I need to multiply by the square root of 2, by just looking at the formula sheet. So y is equal to the square root of 10 times the square root of 2. Since these guys are being multiplied, let's combine their radicals. We get 10 times 2. And sure enough, there's a factor of 2 and 10, so we can make a pair and leave 5 on the inside of the radical for 2 times the square root of 5. And I know that was fast. I'm sorry, guys. Break these up into factors and try it yourself. Alrighty. There's my answers there. And I actually had a student ask me a very, very insightful question earlier. They said, Mr. Shirley, how is that possible? Because if this is the square root of 10, then how is this less than this? Excellent question, okay? It is not less than this. In fact, you're right. The hypotenuse of the triangle is always the longest side. You are 100% right. So the square root of 10 is 3.16, but 2 times the square root of 5 is 4.4, okay? So do you guys see what I'm saying here? Like the radical, being inside the radical reduces your value a lot, right? The 10 goes from being almost 3, okay? And in fact, 9 goes straight up goes to being 3, okay? So being inside the radical reduces your value a bunch, alrighty? Anyways, that is nice. We're already at 20 minutes. Let's try and quickly wrap this up. I do not want you guys to have to watch a 20-minute video. Let's try the next few problems just to show you guys how cool and useful they'll come up later, okay? Special triangles will not go away. We'll do a lot with equilateral triangles and squares, which also have these properties, alrighty? So, for example, on 21 here, find the perimeter of the triangle. So, if this is an equilateral triangle, then these angles are all 60. That means this guy's cut in half, so it has to be 30. Alrighty, so sure enough, this is a 30, 60, 90 triangle. And the hypotenuse, or I shouldn't say that, the long leg of this triangle, which is the height of the equilateral one, is given as 4 times the square root of 15. Okay? If we want to know the perimeter, then I need to get to the outside. But that's tough. What I should do first, like for example, why wouldn't I do that? If I'm looking at my 30, 60, 90 triangle, I have, sorry, I'm trying to get the glare to go away. I have x times the square root of 3. I want to get to the hypotenuse, okay? So if you want to, you could set this up and solve, and it would be possible. What would be easier is just getting x and then getting the hypotenuse. So you guys will see what I say here. I'm going to go get x first, which is this length of the 30, 60, 90 triangle. Okay? So, for example, I have 4 root 15, and this is equal to x times the square root of 3, if this is x. So, you have to divide both sides by the square root of 3 here, and we get that x is equal to 4 root 15 divided by the square root of 3. Now, before you rationalize this denominator, notice that 15 has a factor of 3 in it. So, 5 root 3 divided by root 3 and root 3 cancel, and we're left with 4 times the square root of 5. Okay? But is that our final answer? No. Right? We want to multiply by 2 now to get the rest of this equilateral triangle. So, we'll get that. And let's just call it y or something. I don't know. Y is the whole length. Y is equal to 8 square root 5. Alrighty? But we're still not done. Don't get baited. We can't box in our answer. That's the total length of the outside. We wanted to find the perimeter. And we actually haven't talked about this yet because we did geometry in a different order than the people who made these notes. Alrighty, but that's fine. Perimeter is the length all the way around a shape. Okay, surely you remember from middle school. But anyways, we'll multiply this by 3 to get the length all the way around the shape to get 24 root 5 for our final answer. Alrighty? Almost got you there, didn't I? Didn't I? All right, anyways. If you want to find the perimeter of the square, we can do something very, very similar. If this is a square, then all its angles are 90 degrees. You guys may not know that because we haven't talked about it, but that's okay. A square can be cut into 2 congruent triangles by cutting its diagonal. That means that this angle and this angle have to be the same. And if they make up 90, they must both be 45. Therefore, and I'm sure you guys knew these were 45, 45, okay? But just, as justification, there we go. Now that we know it's a 45, 45, 90 triangle, we have the hypotenuse, which is 28. Alrighty? So you have a TV at home, right? Well, maybe it's not a square. Maybe you can't do that because it's not a square, but what do you have that's a square at home that may be interesting? I don't know. Honestly, anything that's a perfect square. You may have a picture frame or something like that. Anyways. So basically, this is a good question. Like, if you want your square picture frame to have a 28-inch diagonal, which is how they measure picture frames, how much wood do you need along the outside, right? This would be like a good little problem for that. Anyways, so if you take 45, 45, 90 here, we know that 28 is going to be equal to x times the square root of 2. And so we'll take the shortcut here, divide by both sides by the square root of 2. We know that we're going to divide 28 by 2 and then tack on the root 2. Okay? So this is how fast you can do problems if you understand special right triangles. I know that I'm just going to divide by 2 and then tack on a 2. So that's exactly what I did. But we're not done. I need to multiply by 4 to get the entire perimeter, which is, I almost made a huge mistake, 56, I believe. Okay? Yes, 40 plus 60, which is 56. And we leave the root 2 on. There's my perimeter. Okay? I don't know. And for your... Do you see that it just wants us to find the perimeter, so these answers are fine. But like if this was a word problem with a picture frame, it may be a good idea here to take 56 times the square root of 2 to see how much would you actually need. You need the approximation to go to the store. You can't go to the clerk at the guy at Lowe's is not going to know what 56 root 2 is off the top of his head, all right? So you're going to have to tell him something like this. I need 80 inches of wood, And I don't know if they probably don't sell wood in increments of... Well, craft wood they might. Craft wood, honestly, to make like picture frames and stuff, they honestly might do that at like TJ Maxx or whatever that store is. All right. Anyways, guys, that is all I have for you right now. If you have any questions about this, feel free to email me. Okay, what you should do in the meantime to make sure you're on the same page is you need to understand radicals, and then the rest will come after that. Okay.